Welcome back to week 2, everybody. Hopefully week 1 went pretty well for you and probably was pretty easy. Some of you may find that this one is easy as well, but I beg you to watch this anyways because I may have a couple of shortcut ways to do certain things that you learned last year that you may like. Today we're going to talk about solving equations, and I put the most useful thing ever. Really because, not that you do it every day in the real world or anything, but because the rest of your math life, like all the way even till college, this is what it always comes back to, always. And so you really want to be like good at this, like really good at this, maybe even get fast at it. And that is going to help you out in the long run. So what is the main goal or idea here? Well, the idea is that you're going to have a variable and you are trying to solve for the variable or the unknown. Okay, a variable is like your letter, that is the thing that in the problem that it's a number value, a numeric value, but you just don't know what that numeric value is. So you're trying to solve for the variable, and the way that you do it is you want to isolate the variable whenever you have an equation. So isolate the variable on one side of the equals. Okay, so you're going to have, you're going to have all kinds of good stuff, but if you have a problem, then the goal would be to get that X or Y or R or A or whatever letter it is, get it by itself. And there are rules to doing that, okay? And this is one other, these are all just sort of some main points here. So the last main point I want you to write down, because it's super important, is to move across the equals, or to move across the equation, okay, you must do the opposite operation, or math operation. And that's going to make more sense as we do a few examples. So to move across the equals, you must do the opposite math operation. And that's how you make it legal, and you're able to do what you're able to do. Okay, so basic one-step equations. Let us start. So, I don't like blue anymore. I'm tired of you. All right, we're going to go to something like this. Now, I realize you can do this in your head. Okay, 3 plus some number equals 12. Well, you know that that number's 9. You know the answer is going to be 9. But we want to do this with legit algebra because sometimes it's a funky fraction or decimal that you can't do in your head. Okay, so how do we do it? Well, the goal is, remember, to isolate the x on one side. Okay, so if I'm trying to isolate the x, I need to get rid of the 3. That needs to be the first thing to go. Now, right now, that 3 is being added to the problem, and it's a positive 3. So I'm going to try to zero that out. I want to move it away. And the only way that you can move it across the equals is to do the opposite of what you see. So if the 3 is being added, then I'm going to subtract 3 from both sides, and what that does is now it's gone over here, and that's why you do the opposite, because now it's a 0. You're going to bring down whatever is left, which is the x, and then what is 12 minus 3? Well, it's 9. Okay, so that right there is algebra in a nutshell. Do the opposite of what you see so that you can get rid of it, and then you're left with just the x on one side. All right, so that is adding or subtracting to move something over. The next one is, what if the number is actually like stuck to the variable, which actually means that these are multiplied together. So you could probably do this in your head also. Negative 4 times some number is equal to positive 16. Well, you'll probably remember that it should be a negative 4 because a negative times a negative equals a positive. So we know the answer is going to be negative 4, but how can we do that with algebra? Well, the rule is do the opposite of what you see. So right now, if these are being multiplied, then the opposite of multiplication is division. So I need to divide the negative 4 off. And whatever I do to one side, I need to do it to the other. And that's how you make an equation equal at all times. Negative 4 over negative 4, that cancels, right? Y'all remember that a number over itself is just 1, so that's gone. And it leaves just the n. And then over here, 16 divided by negative 4 is negative 4. So once again, that's the algebra way to prove what you already knew in your head. Okay, now here's where I think a trick's going to come in for some of you that think that, you know, maybe you're like, oh, I got this. This is a piece of cake. Okay, these right now are being multiplied, so 2/3 times p equals 5. But this is something you can't do in your head usually, like 2/3 times what number equals 5, or maybe you can do it in your head, but it takes a little bit of thinking. Well, the way that I handle fractions is we're supposed to technically divide both sides by 2/3, okay? But then this looks really messy. 5 divided by 2 divided by 3, like that's kind of weird. And so what I use instead, I'm going to erase this, sorry if you're writing in pen. What I do instead is I like to get rid of this number by multiplying by the reciprocal, okay? Where did it go? Where are you? Okay, there it is. Okay, so I like to multiply instead by the reciprocal. So what I do is I take this side and multiply by 3/2, and I take this side and multiply by 3/2 just because I have to be fair. Now, why 3/2? Why the reciprocal? Well, look at this now, guys. These fractions will now cancel. We talked about cross-reducing last week. Now all that mess is gone, and it just leaves a p. And then it's so much easier to multiply fractions than it is to divide. So 5 times 3/2, well, that's 5/1 times 3/2, which equals 15/2. So it's a lot easier to deal with it that way. Okay, now let's step it up. Let's bump it up a notch, because I know you did a little bit of this last year. Maybe some of you did a lot if you had a really good teacher. Basic two-step equations. Okay. So 2 steps just means that I may have to do more than one thing at a time. So keep the goal in mind of isolating x, okay? Isolate x. And so you to do that, the first thing is if you can combine like terms, please always see if there is combining like terms. Like on this side, see how I have a negative 7x and a positive 2x? Well, my first step would be to go ahead and add those two together, like so. Okay, go ahead and add them together. Then you only have one x over here, and this is what you're trying to isolate. So we're going to get rid of the 4 in the front first, because we did PEMDAS last week, and I made a reference to the fact that when you're solving equations, you end up going backwards, okay? So when we're solving equations, you want to do your add, subtract first, then your divide, multiply, okay? So let's see, we've got a positive 4 in the front, so I'm going to subtract 4 to get rid of it, and that would be a minus 5x, and then over here it would be a negative 21. Yeah, that's the ticket. Okay, then the negative 5 is multiplied by the x, so the opposite of that is dividing it off. So both sides need to be divided. Those will go away. Negative 21 divided by negative 5, well, you can't really reduce those numbers, but a negative over a negative is a positive, so we can go ahead and make that change. Okay, so that's what makes it a two-stepper, guys. We had to do several things at once, okay? We had to first move a number over, then we had to divide off a number. Okay, over here, same thing. Is there anything we can combine over here? No. Anything we can combine over here? No. So let's work on getting this by itself. It's okay that it's on the right. There's no rule about where it has to be. You can leave it there if you like. But the 1 needs to be dealt with and the 3. Now, which one do I do first? Well, addition, subtraction first, so this 1 needs to be moved. Right now, it's a negative 1, so I better add 1 to both sides to get rid of it. Negative 1 and 1, that does make a 0, so I did the right thing here. I bring down the 3r. And now to get r by itself, it's multiplied by a 3, so I need to divide off that 3. And I get r is 7. Yay! Fun! So if you don't like the fact that this is on the right, then once you get finished, move it to the left. I mean, it doesn't matter. It's the same thing. Okay. The last one on this section is right here. Okay, we've got a y that's in an interesting position. You may not like how this is written, and if you don't, I want to remind you that a y in the numerator just means that there's an invisible 1 in front of it. And if that's the case, this y can actually be written behind it instead of on top. Okay? So you can rewrite this term as minus a 1/2 times a y. That is the same thing as that. So if you didn't know that, it's kind of cool to know now. You can ask me about it if that doesn't make sense. But that's pretty much it. If it's in the numerator, just push it to the back, and there was an invisible 1 in front of it. Okay? Now we do just like on this one. You want to get rid of the add or subtract part first. So I'm going to subtract 2 to make that a 0. I'm going to recopy all this. 8 minus 2 is 6. Okay? Now, I could divide by a negative 1/2, but I told you if there's a fraction in front of my number, instead I like to multiply by the reciprocal. So the reciprocal of that is negative 2 over 1. So I'm going to do negative 2 over 1 to both sides. That cancels out everybody. And then 6 over 1 times negative 2 over 1 is in fact equal to negative 12 over 1, which is the same thing as just negative 12. Alright, cool. Hopefully this is going pretty well for you. We're going to do some multi-step now, so these are a little bit uglier. But it's only adding one component, and the one component that this section is adding is the whole parenthesis business, okay? So I know that like with PEMDAS we do what's inside the parentheses first, but when you're solving an equation that's got parentheses, you want to distribute first. Distribute first. And you probably remember from middle school that distributing means that this number is multiplied by both of those in the parentheses. So what we're going to do is do 6 times x and then 6 times negative 1. Well, 6 times x is 6x, okay? 6 times negative 1 is a minus 6. And that's it. It adds that one step, but now this looks just like the ones we did a second ago, okay? We're trying to isolate 6, so do we do the multiply one here first or the subtraction first? Well, we do the add subtract first, because we're working backwards from PEMDAS. Those are a 0, that's a 16. Bring down the 6x. Okay, now how do I get the 6 off the x? Divide it off. Does that reduce? I believe so. So that's going to be 8/3, and then I will quit. Yay! Alright, this one looks mean, but it's the same dang thing, right? Except you're going to distribute twice. Alright, so 2p, or 2 times p is 2p. 2 times a positive 3 is a positive 6. Now over here, same thing. Negative 5 times p, and then negative 5 times 4. So that would be a negative 20, okay? Now we've got p's on both sides, and we've got numbers on both sides. So you get to decide, like, where you want your variable to be. I like to keep them on the left if they're already on the left, which means this one I do not want over here. I want this one to be over here. So my first step would be to add 5p to both sides, because what that'll do is it'll cancel it right here, because that makes a 0 when you put them together. And over here I'm going to have 7p plus 6, and then I'll carry down the negative 20. Okay, now it looks just like this one over here. I need to get rid of the add subtract part first. Then I can divide off the number that's stuck to p. And that does not reduce, I don't think. So negative 26/7 would be my final answer there. Okay? Now just because there's fractions doesn't mean it's horrible and mean. It just means it's going to slow you down a little bit. But it's the same dang thing. I like this one being on this side. I don't like this s over here. So my first step would be to subtract the 1/5 s from both sides. And so I'm going to bring down that 3. 4/5 s minus 1/5 s. Well, you get to add fractions now, don't you? And when you do that, you're going to get a negative 1s. And that's because 4/5 and 1/5, when you put them together, are 5/5. So it's going to look like that. And then now these are gone, and we got rid of them, and just a 1 is left. And so it looks like normal now. I can get rid of the minus 3, minus 3. What is 1 minus 3? Negative 2. And then there's a negative 1 in front of that s, so we're going to divide it off. And so s would be positive 2. And that would be how you can deal with it. Now, this last box here is just for you. It's like, what are some things to keep in mind? Well, You know, this is for you. Whatever you thought was interesting, go ahead and make a note of it. If you liked that reciprocal trick, write down reciprocal trick. If you think you might forget to distribute or what distribute means, write down what distribute means. I think one of the most important things is what I was saying about with PEMDAS, we're so used to doing this, but when you're solving, you are doing SADMIP. You are doing this first, then that, okay? And we haven't really had the whole like exponent parenthesis mess that we have to deal with. That's going to come like closer to Algebra 2, so don't even worry about that, okay? But that's what you need to be able to do. All right, cool. Go ahead and try the homework, and good luck to ya.